All right, hello, welcome to the USAFA Chemistry Lab. Today we will be doing the Density of Matter lab. So this is a fairly simple lab where we're going to measure density, but we're going to do it in potentially a way that you haven't done it before. So as you know, density rho equals mass over volume. You could rearrange that equation to be read as mass equals density times volume, and in that way you can plot it. So we're going to do that in a minute. Actually, we can, just one note on measuring the volume. So this is a burette if you haven't used one before. And we'll measure our volume from the burette. So the volume measurements look like they're upside down. That's because the water in this case is leaving the burette, and that's how we're going to measure that volume. But the graduation is by the tenths of a milliliter, excuse me. So you can measure 1/10 of that graduation. So we're going to measure here at 11.26 at the bottom of the meniscus here. So you can report that as volume equals 11.26 plus or minus 0.05 milliliters. And this uncertainty is specific to the burette, the glassware itself. Okay. So first thing we're going to do is fill our burette with water. Couple things to remember when you're filling a burette. The first thing is to always fill it at below your eye level, okay? And the second thing is to always make sure the stopcock is perpendicular to the burette itself. This way lets the water out, this way keeps it in, okay? So we'll go ahead and fill it. Okay. Like that. And seat it nicely in the burette holder. Okay. And the third thing to remember is before you measure the volume in the burette, you want to always make sure that the tip of the burette is charged with water or full of water. So no bubbles, full of water. Now our burette is ready to measure. And we'll take that funnel out. Okay, so now the first thing for this lab, we're going to measure the density of water. So we need to be able to measure the volume of the water, which we'll do with the burette, and we need to measure the mass of the water, which we'll do with a mass balance in the beaker. So if you want, you can mass this beaker. So we'll do that. I won't do that on camera, but we'll mass the mass of the beaker, and then we'll put this dry beaker underneath the burette, and it doesn't matter what the volume is here as long as you know the volume exactly. Okay, so we can use this little card to see it, and again we're going to measure to because the graduation is to the tenths of a milliliter, we're going to measure to the hundredths of a milliliter, estimate to the hundredths of a milliliter. So we're going to say that's about 10.59. Okay. Now we're going to dispense approximately 5 milliliters of water. And again, it doesn't matter it doesn't matter how much you dispense as long as you know exactly how much you did dispense. Okay. So we're up there at 10.5. We'll go down to roughly 15.5. About there. Okay. So now we measure the volume again, and we'll call that 15.76. Okay, so you've got two volume measurements. You take the difference. That's the volume of the water in your beaker. Okay, so bring up our chart now. We've got the volume. Okay, now we already took the mass of the beaker. That would be the mass at 0 volume. So that's right here. Okay. Now we go ahead and mass this beaker with the water in it, and we get maybe here. Okay? And then you're going to repeat that procedure 4 more times. Okay? So we're at about 15.5. Empty some water from the burette. Go down to about 20.5. That's 21.5, but it doesn't matter as long as we know what the volume is exactly. So we've got 21.47, okay? And then we take the mass of the beaker and all of the water again. So this is a total mass, thank you, total mass and total volume. So now we have maybe a measurement like here and the point here. We do it again, we get another point, we do it again, we get another point, we do it a fifth time, we get another point. That's going to form a line, right? And there's our familiar equation for a line, y equals mx plus b. This time it's m equals rho times volume plus the y-intercept, which we know is the mass of the beaker. Okay. And so you can put all this data into Excel, and we can determine the mass, the density of the water from the slope of that line. Okay. So that is part one. I think you put it down. The second part of this lab is to measure the density of an unknown metal. Okay, so I have here two different metals. In the lab, you'll have 4 different metals. They each have a number. This is number 3. This is number 4. Let's do number 4. Okay, so the first thing you're going to need to do to determine the density is to weigh the little metal slug. Okay. Actually, first you want to actually look at it and make some observations about it, right? Is it gold? Is it silver? Is it black? Does it feel heavy? Is it rough? You know, general observations. Okay. So after that we'll go ahead and go to the mass balance, get the mass of it, and then we'll measure the volume by a displacement of water. Okay. So to do that, we'll take a 50 milliliter graduated cylinder. We'll add to it probably between 15 and 20 milliliters of water. And then we'll add to this our slug. And this is an important part. Do not just drop the slug in, because it will do 2 things. It will crack the bottom of the graduated cylinder, and it will also splash some of your water out. So in order to do this effectively, you want to tip it at a pretty serious angle and just slide the metal slug in. And be sure not to splash the water like that, okay? And actually, you should have taken the measurement of the water before you did this, so be sure to do that when you do the lab too. So then you can take the final volume, and then you can subtract the final volume from the initial volume, and that is the volume of the cylinder. Okay. One note on measuring the volume of a graduated cylinder is that this is graduated in increments of 1 milliliter instead of increments of a tenth of a milliliter like the burette. So in this one, you'll measure to the tenths of a milliliter instead of the hundredths. So to measure that, make sure it's flat, get to eye level, and then use your card again, and you can, and this is about 21.1 milliliters. Okay? So you have, and for the case of the metal slugs, you're not going to plot it on a plot. You'll just use mass over volume. So you have the mass from the balance. You have the volume from the displacement of the water. You'll do this, empty this, and do it 2 more times, and then you'll be able to. Then you'll take the average of that to have the density of the metal. You can compare that to the metal densities, which are also in your lab handout, or you can look them up online. And then, so you'll do that 3 times for the first metal, and then you'll do that 3 times for a second metal, and you'll determine the density of 2 different metals. And that completes this lab.